Welcome to the crime family, partners. Hey class, today we're going to be solving equations. And if any of you have seen Scooby-Doo, when he sees a problem, you know what he says? Ruh-roh. So now we're solving equations. We're past Scooby-Doo by now. When solving equations, we use what we call inverse order of operations. So if we talked about inverse before, we've talked about reciprocals, what that means, but inverse order basically means backwards order. So backwards order. It's kind of like reciprocals and inverse because it's flipped around. So is order of operations. So we use the inverse order, let me spell that correctly, of operations. So what that means when we have PEMDAS, or please excuse my dear Aunt Sally, instead of using the parentheses first and we went to the right, now we go from the right to the left. So we will do addition or subtraction first, followed by multiplication or division, then we look at exponents, then we look at parentheses when we are going last. So let's move on. We have a few definitions here. First off, an open sentence is any equation that has a variable. So an open sentence is any equation that has a variable. Pretty basic. An equation, okay, is what we would say as follows: a mathematical equation, a mathematical, we can't use the word in the thing, a mathematical phrase that has an equal sign. So a mathematical phrase that has an equal sign. So now let's do some problems. We are going to start solving for the mystery, just like Scooby-Doo was. Up there he is again. So we're solving for our mystery. We're using inverse order of operations. So the first thing we always want to do is try to get the variable by itself. So here we want to try to get C by itself. The way we need to do that is by doing the opposite. So we look at what is on the same side of the equal sign as C, which is the C minus 1. What is the opposite of subtraction? Well, it is adding 1 to both sides. So when we do that, we need to show our work as so. We would end up with C on the right. On the left, 4 plus 1 is 5. So we would get 5 is equal to C. And always I'm going to write our variable on the left-hand side because that will help us a lot in the future. So we have C equals to 5. You can always check your answer. If we would take our answer, plug it into the original equation, 5 minus 1 is equal to 4. So we would know that we did that correctly. Number 2, we have 12x equals 48. We know right here, in between the x and the 12, they are multiplying. So we need to do the opposite of what is happening. So that is to divide both sides by 12. Again, we're using division by showing it as a fraction, like we talked about earlier. 48 divided by 12 is equal to 4. And we can always plug it back into our original equation. 12 times 4 should be 48. If that does not work, you did something incorrect with your work. Okay, something happened. I may be redoing this again. I'm not sure. But if so, you can just speed it up a little bit to the next one. So we want to get x by itself. We have this 2 on the same side of the equal sign. It is a negative 2. We always look like what is in front of that variable, which means on the left-hand side, or that number, sorry, not variable. So we would go and we want to get x by itself. So we would need to add 2. The reason why is negative 2 plus 2 is 0, so those cancel out. So we bring down our x, and we have 7 plus 2, which is 9. And we can always go back up, plug it back in, see if it's right, in which it is in this case. So number 4. Now we're on a two-step equation. So we have two things that are happening. We have this division sign and we have this addition sign. This is where inverse order of operations is a big deal. So we need to do the opposite. We always do adding and subtracting first. So since it's adding, we do the opposite and we subtract 1 from both sides. So that cancels out to get 0. So 2 minus 1 is 1. And then we bring down our y over 3. So now it's y divided by 3. What's the opposite? Well, it is multiplying by 3. So we're going to multiply both sides by 3. And I'm going to show multiplication by drawing parentheses, because it's multiplying everything on each side by 3. When we get more complicated problems, that will become a bigger deal to make sure that you do parentheses. So we'd have y is equal to 3. Again, we plug it back in up at the top. 3 divided by 3 is 1. 1 plus 1 is 2. So that checks out. Problems 5 and 6. For number 5, again, two-step equation. Always do adding and subtracting first. So we need to subtract the 5 from both sides. So that will cancel out to get 0. Bring down our 2a. We have 13 minus 5, which is 8. And then we have one step left where they are multiplying. We need to divide and do the opposite. So a is equal to 8 divided by 2, which is 4. Number 6. As you can see right here, we have two p-values. Something that's not in the order of operations is combining like terms. Always get one variable first. So we have two variables right now. They're both p. We need to combine like terms. So if we combine them together, we are going to get negative 26p. Then we have the plus 18, then equals 5. Now that our like terms are combined, we need to make sure and solve for p. Now we go back to inverse order of operations. So adding and subtracting first. So we subtract the 18 because positive 18 minus 18 is 0. And we bring down the negative 26p. And 5 minus 18 is negative 13. So we take both sides and divide them both by negative 26. So those cancel out there. On the right hand side, negative divided by negative makes our answer positive. And it would be a positive 1/2 because both of those are divisible by 13. If you wanted to write 0.5, that would also be an acceptable answer. Alright, head on to your IXL.